Data Nation. Matt here with a video that will teach you the essentials of the Python programming language. Timestamps are provided if you prefer to skip around. A link to the repository with all of the code in this video will be available in the description. Since this is a slightly longer video than usual, let's go ahead and get started. Starting with basic mathematics in Python, we can add numbers together and print out their result to the terminal window. Type print with 10 plus 15 inside the parentheses. Save and run this code and you should see 25 in the terminal window. If we change at least one number to a floating point data type, then the result will be a float as well. So change the 10 to a 10.0 and save and run. Now you should see 25.0 in the terminal window. Before we type and run our next code, let's go to the terminal window and type clear and then press enter. This will clear the terminal and allow a clean slate for the next output. We can also subtract numbers. Let's subtract 8 from 108. In the terminal window, you should see 100. However, just like with the addition example, if you change one of the numbers to be a float, then the result will be 100.0. Go ahead and clear the terminal again, and let's move on to multiplication and division. Use the asterisk symbol to multiply numbers. Let's multiply 2 and 10. You should see 20 in the terminal window. Let's divide 200 by 2. This time you will notice that the result is a float even though neither of the values we typed in are floats. Why does division return a float? With regular division, the result is typically a fractional result, even though the operands may be integers. Floor division, also known as integer division, will return just the integer portion with the decimal cutoff. Use two division symbols to denote integer division. Let's do integer division with 5 divided by 2. The result should be 2. If for some reason you wanted a floating point, which you could use the standard division to achieve that instead, you can change one of the values to a floating point decimal. Moving on to the modulus operator. This will give us only the remainder after integer division. Use the percent sign for the modulus operator. For example, 5 divided by 2 is 2, but with a remainder of 1. So 5 modulo 2 is 1. We can also perform exponentiation. You can use 2 asterisks to denote exponentiation. 2 to the power of 3, or 2 to the third, is 8, as you can see in the results window. There's also the order of operations that Python follows, PEMDAS, PEMDAS, which stands for parentheses, exponents, multiplication, division, addition, subtraction. Let's type in 5 plus 2 times 1 plus 2 minus 8 divided by 2. Under the order of operations, the result should be 7. However, with Python, we'll have 7.0 in the results window because there's division inside of the equation. To print text on a screen, you simply type print with the string that you want inside single or double quotes inside the parentheses. Here is a string using single quotes. And here is the same string using double quotes. Both give the same text in the terminal window. But what if we have an apostrophe in the string? If you run this code, you should get a syntax error because Python saw the beginning quote and the ending quote after the word here. Then, the quote at the very end of the string is a new beginning quote without an ending quote. We can fix that in multiple ways. One way to fix this would be to use double quotes if you have an apostrophe inside the string. Another way to fix this is to use the escape sequence with the backslash before the apostrophe. This tells Python that there's a special character inside of the string. The same goes for double quotes that are inside strings. If you run the following code, you should get another error. We can fix it by using either single quotes on the outside of the string, or by using the escape sequence that we just mentioned. You can also convert strings to numbers. If the string is a number, you can convert it to a numeric data type. So let's convert 123 from a string to an integer, and then display its data type by using the built-in type function. In the terminal window, you can see class int, so we know that we converted the string successfully. However, if you try to convert a string to a numeric data type, but the string is not numeric, you should get an error. You can also convert a string to a float. Let's check the type just to make sure we did it correctly. And as a final example, you can convert numeric data to a string type. Let's convert the number 123 to a string and print the data type so we can make sure we converted it correctly. You can think of strings as arrays of characters. Therefore, you can use indexing to select certain parts of the string. Note that indexing in Python begins at 0, not 1. So the first item in an array is at index 0. Let's get the first character in the string hello world. We do this by placing square brackets at the end of the string and then placing the index that we want inside the brackets. Selecting the first character by using index 0 should give us H. Now let's select the 9th character, which should be at index 8. This should give us the letter O. You can also select a range of characters inside the string. Note, however, that the last index in a range of indices is not included in the selection. So selecting 0 through 5 will actually give us indices 0, 1, 2, 3, and 4. You can do more complex indexing if you'd like. Indexing is laid out with the start index first, then the stop index, and finally a step index, which tells Python how many characters to move before selecting another character. For example, we can select every other letter by placing the start index at 0, leave the index for the stop blank to let Python know that the end of the string is where we want to stop, and then for the step, put 2. This tells Python to select every second character. Although we haven't talked about functions yet, the input functionality allows you to get input from the user running the code. When you run the following code, you will be prompted in the terminal window to provide input. You can use a new line character so that the user can input their response in the space below the prompt. If you don't use the new line character, the response will be typed right next to the prompt like this. This will not affect the program at all, but it's always good to be mindful of the user interface that you are creating and to make it as appealing and intuitive to use as possible. String formatting is useful when you have variables to be placed inside strings or you need to make data type conversions on the fly. But for now, just to show the functionality, let's just show how to use placeholders. Inside of the string, you can place empty curly braces and then after the string, type .format with the strings that you want in each placeholder in order. You can set the order however you'd like if you place the order numbers inside the curly braces. For example, let's put 0 first and 1 second, which is the default ordering. You can also use the same string multiple times. So let's put 0 in the first one and 0 in the second one. Now let's reverse those and put 1 first and 0 second. Then you can see that the strings have been switched. You can align your text in the terminal window. The left aligned text is the default alignment, but there are 2 spaces at the end of this text because this left aligned string only has 27 characters, and we use 29 characters as a reference. The right aligned text contains 28 characters, so it makes sense that by right aligning based on 29 characters, that should give us 1 space at the beginning of the text. The centered string only has 23 characters in it, so centering it gives 3 spaces on each side. We can fill these spaces with a specified character. Let's use the dollar symbol. You can format data for a report to have the comma thousands separator using curly braces with a colon and a comma inside of it. You can also allow the plus for positive values and the minus for negative values to be visible using curly braces with a colon and a plus F. Or you can just show the minus sign when applicable by using the curly braces colon F. Finally, you can set the precision on decimals to 2 and give the value a percent symbol by using curly braces colon 0.2%. Variables are objects in Python. We will discuss objects and classes in a future video, but for now just understand that you can store data inside of a variable to use later. You do not have to specify the type of the variable like you do in some other programming languages. Let's create an age variable and set it equal to 31. And next, let's create a favorite color variable and set it equal to magenta. It's okay and actually good to be verbose with variable names and function names so other users know what they are used for. Just make sure that variables do not use reserved keywords from Python. And of course they can't have spaces, so use underscores. You can use uppercase or lowercase depending on your preference, but I will use lowercase here. If you run this code, nothing will show up in the output window, but you'll know that Python is storing magenta in favorite color and 31 in age. Recall from the string formatting section of this video that we can put placeholders inside strings and then assign values to those placeholders. In this case, we want to assign variables to the placeholders. So let's print out a message that tells us how old we are and what our favorite color is. Now let's add 1 to the age. You can do this by setting age equal to age plus 1. Note that if we assign a new value to a variable, the old value will no longer be stored. Another way to increment by 1 is to use the shortcut plus equals. Let's also change the favorite color to purple. Many times you want to know if something is true or false. This is where Booleans and logic statements can help. A Boolean value is true or false, or 1 for true and 0 for false. We can have Python test statements for us to determine if they are true or false. Set 3 variables x, y, and z to 1, 5, and 1 respectively. Now let's run some condition checks. Using your awesome math skills, you know that the first and the third conditions are true, and the second one is false, which is displayed in the results window. You can also compare strings. Although they are the same letter, one is an uppercase A and the other is a lowercase a, and computers store letters as numbers known as ASCII, ASCII values. Capital A has an ASCII value of 65, and a lowercase a has an ASCII value of 97. That's why it shows that capital A less than lowercase a is true. Now let's go over and or inside of logic statements. We can use the ampersand symbol to denote and. This tells Python to check that both conditions in the parentheses are true. If so, then the result is true. If at least one of them is false, then the result is false. Here's an example using and, where one of the conditions is false. Therefore, the result is false. The or symbol is the pipe symbol. The result will be true if at least one of the conditions is true. If you have experience with programming, then you probably know about if, then, else statements. If a condition is met, then do something. Otherwise, do something else. Let's create a variable, a, and set it equal to 10. To create an if statement in Python, we type if followed by the condition to check, and then a colon. Let's check if a is less than 10. Pressing enter after the colon in Visual Studio Code should automatically place the cursor in the correct space to begin typing the instructions for the program if the condition is met. White space is important in Python, and 4 spaces should be added before the instructions. If the condition is not met, then Python looks for the next condition check, which is denoted by elif, which stands for else if. The second condition that we will check is if a is greater than 10. Finally, if none of the conditions are true, then we can set a default value in the else statement. If a is not less than 10, and it is not greater than 10, then it must be 10. Let's change a to 5 and run the program. And now you can see that a is less than 10 was printed because the first if statement was true. A list can contain any number of elements, including 0 elements. We can create a list by using square brackets. Let's create an empty list called list_a and print the list and its type. You'll see class list in the results window. A list is ordered, which means that while 2 lists may contain the same elements, that does not necessarily make them equivalent. Let's create 2 lists, list A and list B, with the same elements, except one of them is reversed. You can see that list A is not equal to list B. A list can contain elements of different types. For example, let's assign a list of strings, integers, and a float to our list A variable and print it out. You can also have a list of lists. This is also known as a nested list. Let's create a list with 2 lists inside of it as its elements. 1, 2, 3, and 4, 5, 6. So notice that the 2 elements inside list A are lists themselves. The nested lists each have 3 elements. This is something that you should see quite often in your data analytics career when you deal with matrices and linear algebra. This is also considered a 2-dimensional array. Indexing multi-dimensional arrays is slightly more complex than indexing single-dimensional arrays, so let's start by indexing elements in a simple single-dimensional array. Let's use list A, which is equal to 1, 2, 3, 4, 5. Recall that the indices begin at 0 and they end at n-1, where n is the number of elements in the list. So to select the first element in the list, we use square brackets with a 0 inside after the object we are indexing. You can determine the length of a list by using the len function. Let's assign the length value to a variable called listLength, and then use that to select elements in the list. Remember, the last index is not included, so this will only print out the 0, 1, 2, 3, and 4 indices. Lists are also mutable, which means that you can alter elements in a list. Let's change the third element in the list, which is the second index, to 10, and then print out the list. You can also append or prepend items to a list. Typing list A plus equals and then another list of items will add that list of items to the end of the original list. Typing list A equals followed by a list plus the original list will add items to the beginning of the original list. There's a lot more to do with lists in Python, but this was just a short introduction to their basic functionality. Tuples are similar to lists, but they are not mutable. They typically have more than one element, but if you have a tuple with only one element, you initialize it as a tuple by using parentheses and a comma after the first element. Otherwise, Python will see just the element and not a tuple, like you can see in this example here. So why would you use a tuple instead of a list? Well, tuples are actually immutable, and so if you don't want the elements to be edited, then you would use a tuple instead of a list. Also, execution time is known to be better with tuples when dealing with large sets of data. You can also unpack a tuple, which means assigning each element to a variable. In other words, you are separating the tuple into its individual parts. Now let's go ahead and move on to Python loops. Create a list of grocery items and call it grocery_list. We can use a for loop to loop through each element in the list and print it out. You create the for loop by typing for, followed by a placeholder variable, and then in, and then your list name. And then inside the loop, you will be able to do things with the placeholder variable. In this example, I'm going to use G as my placeholder variable. This is similar to the if-then-else statement with the white space because you need 4 spaces before the set of instructions in the loop. In this for loop, we just want to print the elements out. We can also perform logic checks inside the loop and either break out of the loop, skip part of the loop, or just do something else. The break keyword will actually break out of the loop if the condition is met. For example, you can see that the loop printed out apples, oats, and almonds, but stopped once it saw blueberries. The continue keyword will skip the condition but continue on with the rest of the loop. For example, you can see that blueberries was not printed out in the results window. The range functionality is useful when loops have a definite number of iterations. If we print out the results of range of 3, we can see range 0, 3. So we can use this functionality inside of a loop. Let's loop through the range of 3 and print each value and the value plus 1. So for I in range of 3, print I, I plus 1. So the loop will start at 0 and end at 2 because of course the last index is not included. Then there is the while loop, which will run until a condition is met. For example, let's create a variable a and set it equal to 0. Now we can create the while loop and have it check if a is less than 5. If it is, then it runs a set of instructions. In those instructions, we should increment a by 1, otherwise a will always stay 0 and the loop will run forever. While a is less than 5, print a, and then increment a by 1. In the results window, you should see that the loop stopped when it printed 4. To define a function, Use def, which is short for define, followed by the name of the function and a set of parentheses. Inside the parentheses, you can include parameters. Let's create a function called addNumbers, which takes two numbers and adds them together. The return statement is telling Python that this is the result that we want to return to the user. However, this is not the same as print, so when you call the function, you can either store the result as a variable, or you can print out the result using the print function. If a user calls this function, they should also provide arguments, which will take place of the parameters in the function. To call a function, just type in the function name followed by parentheses, and then include the arguments inside the parentheses. Let's call the addNumbers function using the arguments 5 and 10, and let's print the result out. You should see 15 in the results window. Let's create a new function called automated_greeting, which takes a name and an age and performs logic checks. If the age is greater than or equal to 30, then print a message. Otherwise, print a different message. Let's call the function with an age greater than 30, and then call it again with an age less than 30. Importing a library is what makes Python so useful for data science. Someone has already done all the work to write a bunch of functions and code that makes common tasks easy for us to implement. For example, in data science, you may need some functionality from the math library. So let's import the math library by first typing import and then the library that you want to import, which is math. You can then access functions and other pieces of a library by first typing the name of the library and then a dot, followed by the name of the function, method, or constant that you'd like to use. For example, let's print math.sign, and in the parentheses, math.pi divided by 2. And this will give us the sign of pi over 2. And in the results window, you should see 1.0. And there you have it. That is a lot of basic functionality for Python to get you started in your data science journey. We will begin covering specific Python libraries such as Pandas, NumPy, TensorFlow, and so many others in future videos. I'll see you in the next one.